Hello, good morning. So I'm going to go through the homework solutions from the work you had on Monday. And then for the rest of today, I do want you to do some practice with the revision exercises in probability. Now, I'll have spoken to you this morning by the time you see this, but we're going to have a short probability test, a multiple choice one, on Tuesday. So on Monday, there's a school event, so you don't have classes. And on Tuesday, then you'll have a probability test. So today is the last time we're practicing in class. And tomorrow we are starting a new topic because we have a double class. So after the solutions of the work you do today, you will have, we'll be starting a new topic then. Okay, anyway, let me go through the homework solutions and you can let me know if you have any questions on these. So for question 4, the question said around 90% of people are right-handed. In a survey of 1,500 people, that's my total, how many would you predict to be left-handed? So hopefully this was something you could think through. So you can do it by probability. So the probability of being left-handed will of course be 10%. If 90% are right-handed, then 10% are left-handed. Now, there's an assumption we're making here that nobody is ambidextrous, but they didn't give us enough information, so we'll just have to go with 10% left-handed. And so then you're multiplying that by the total, so 10% of my 1,500, which is, change it to a decimal and multiply. And we get 150 left-handed people. So that's what we would expect. Of course, you don't have to show all of that writing down that I did there. Even just this final line here would be enough to show the work. Okay, question 5 then. A study finds that 20% of people, well, that's higher than I thought, are allergic to cats. In a school of 550 students, how many people would you expect to suffer from this allergy? So we expect 20% of 550, which is, change it to a decimal and multiply. 0.2 multiplied by 550, and that is 110 people. So we expect 110 people in a school of 500 to be allergic to cats. Now, the study also finds that 50% of the people, so if you're allergic to cats, if you're already allergic to cats, then 50% of those people will also be allergic to dogs. So how many of the 550 students would we expect to be allergic to dogs? Well, we'll only look at those who are already allergic to cats. So we'll say it's 50% of the 110 that we got in part A. So that's 0.5 multiplied by 110, which is 55 people. Okay, you may have noticed that there's a bit of a problem with the last two questions in that, this one here, question 4, didn't consider people who are not left-handed and not right-handed. They didn't consider ambidextrous people. This question here didn't consider those who are allergic to dogs but not allergic to cats, which is also a possibility. But you just have to work with the questions as you're given them. And they're estimates. So when we're doing probability and statistics, it's not an exact science. We can get exact numbers, but how likely are those to be true depends on how big the numbers are that we started with in the first place. Okay, and moving on then to question 6. We have an unfair six-sided die. So it's unfair, and it lands on 4 30 times out of 100. So what we can say from this, the probability of it landing on 4 when it's an unfair die, we have to use relative frequency. So the probability of it landing on 4 has to be the relative frequency of it landing on 4, which of course is the number of times that 4 came up out of the number of times that we tried. So we have a 3 in 10 probability of it landing on 4 when it was an unfair die. So then in part A, we're asked how many times would we expect it to land on 4 if we rolled it 300 times? Well, 3 times as many, right? We're going to multiply that by 3. Or we'll just say the expected frequency is always going to be the probability multiplied by the number of trials. And in this case, my probability is the relative frequency. So the expected frequency will be 3/10 of 300, which ends up being 90. So we expect it to land on 4 90 times out of 300, which as you can see is the same as, so 300 is 3 times as many as 100, so it will be 3 times 30. That's another way of thinking about it. But we can just rely on our formula, which is sometimes easier when you have all these questions to work through. How many times would it be expected to land on 4 in 600 rolls? So it's 3/10 of 600 this time, twice as many as this, so that would be 180 times. And finally, part C, how many times would a fair 6-sided die be expected to land on 4 in 600 rolls? So if it's fair, the probability is going to change. The probability of it landing on 4 will no longer be 3/10, it will be 1 in 6, because each of the numbers has an equal probability of coming up. So it's 1 in 6. And I would expect 1/6 of my 600 rolls to be 4, which is that I would expect it to land on 4 100 times. Okay, so hopefully that's clear. We're going to do a little bit more practice with probability before we move on one of the revision exercises today. I don't want to give you too much work, and then we're going to move on to a new topic. Okay, thank you.